Problem 1. Use the vertex and intercepts to sketch the graph of the quadratic function. Give the equation of the parabola's axis of symmetry. Use the graph to determine the domain and range of the function. All right, so looking at the function, it's given to me in standard form, so I can look at it and determine what the vertex is. The vertex is the number that you're subtracting from the x, so it's going to be -3. It's been shifted to the left 3 units because of that +3, and it's been shifted down. The constant outside that x plus 3 squared is the y-coordinate of the vertex, so that is -3, -1. The axis of symmetry is the equation x equals the x-coordinate of the vertex, so that is x equals -3. The domain of all parabolic functions is the set of all real numbers, -infinity to +infinity. This is a parabola that opens up, and I know that because the leading coefficient is a +1. So since it is a parabola that opens up, it has a minimum, and that minimum is the y-coordinate of its vertex. So the range goes from that minimum to infinity. So it's going to be from -1 to infinity. And yes, you do use a bracket next to the -1 because the point -3, -1, the vertex, is on the graph of that parabola. So you're going to include that in the range. All right, so then you're going to graph it, and it tells you to use an intercept. Probably the easiest intercept to find is the y-intercept because you just evaluate the function at 0. So that's going to be 0 plus 3 squared minus 1, that's 9 minus 1, that is 8. So when you graph this, you're going to pick the parabola tool from your toolbar. You're going to plot the vertex, -3, -1, and then you're going to move up and you're going to plot the y-intercept. And that will give you the graph of this thing. Something like that. All right, problem 2. Consider the function f of x equals -3x squared plus 30x minus 9. Determine without graphing whether the function has a minimum or a maximum value. Well, this is a parabola that opens down because the leading coefficient is -3. So it is going to have a maximum. What is the maximum? Well, the maximum is the y-coordinate of the vertex. So I need to find the vertex. The x-coordinate is -b/2a, so we do have a formula for the x-coordinate of the vertex. It's a plug and chug. So it's going to be 30. Better put the negative in there. -30 divided by 2 times -3. Negative divided by negative will give me a positive. 30 divided by 6 is 5. So this vertex occurs at x equals 5. What is the maximum, the y-coordinate of the vertex? That is the function evaluated at 5. So -3 times 5 squared plus 30 times 5 minus 9. I'm going to plunk that into my calculator, and my calculator says that is 66. Again, the domain of a parabola is the set of all real numbers, -infinity to +infinity. This is a parabola that opens down. It has a maximum. So the range is going to start at -infinity, and it's going to end at the y-coordinate of its vertex. So the range is -infinity to 66. And yes, put a bracket next to the 66 because the vertex is a point on this parabola. Problem 3 is matching. you're going to determine which graph fits which equation below. And I do believe these are fairly straightforward. For example, I'm going to look at that first graph on the left. That first graph on the left is an even degree function. It's an even degree function because both sides go up. It goes up to the left and up to the right. It's also going to have a leading coefficient that is positive because it is going up to the left and up to the right. So an even degree function that rises to the left and to the right is a even degree function with a leading coefficient that's positive. It has to be this one. Has to be that one. All right, the second one is an odd degree function with a leading coefficient that's positive because it's falling to the left and rising to the right. So I believe that is the one it has to be. The third graph from the left is an odd degree function with a leading coefficient that's negative because it's rising to the left and falling to the right. So that has to be this one here. And then the last one is an even degree function whose leading coefficient is negative, and that has to be the first one here. So you're going to drag and drop the correct graph to the correct equation. Problem 4 is really simple. Using the leading coefficient and the degree, determine the end behavior. It's a fourth degree polynomial function whose leading coefficient is negative. So it is going to fall to the left and fall to the right. That would be A. Problem 5. We're going to be doing multiple steps in this particular problem because this is the step-by-step process we use to graph a polynomial function. Now, again, I highly encourage you to take your calculator out and graph this on your calculator also. All right, but I do have to answer all these questions. Part A says to use the leading coefficient to determine the graph's end behavior. So I'm going to find the leading coefficient. So I have a -3. And from this term here, let's highlight this. From this factor here, this factor, if I were to multiply that all out, I would get an x squared. So we're going to write that down. The leading coefficient of that factor, x minus 3 squared, is x squared. And then the next one, the leading coefficient, the next factor, the leading coefficient is x squared. So we're going to have that in our leading coefficient also. So if we were to multiply this all out, our leading coefficient would be -3 x to the fourth, which means that is an even degree polynomial function whose leading coefficient is negative. It's going to fall to the left and fall to the right, which is the last choice there. Now find the intercepts. To find the x-intercepts, we set each factor that contains an x equal to 0. So we're going to set x minus 3 squared equal to 0. And we're going to set x squared minus 1 equal to 0. And then we're going to solve those two quadratic equations. The first one, the one on the left, I'm just going to take the square root of both sides. And the square root of 0 is just 0. There's no sign there because 0 is not a signed number, S-I-G-N-E-D number. So it's just going to be 0. And the left-hand side's x minus 3. Add 3 to both sides, we get x is 3. So one of our intercepts is at x equals 3. Now the right-hand equation, I think I'll factor that. That is the difference of two squares. X squared is a perfect square, as is 1. So you're going to write this as a sum times a difference. It's the square root of x squared, which is x in the first spot, and the square root of 1, which is 1 in the second spot. So we're going to set x plus 1 equal to 0. we're going to set x minus 1 equal to 0. So we get -1 and +1. So -1 and positive. All right, the next step is to determine what the graph is doing at these x-intercepts. So we need to look at the multiplicity of each of these x-intercepts. If we look at 3, 3 was found from the factor x minus 3 squared. So the multiplicity is 2. Since that is being raised to the second power, its multiplicity is 2. Now on this side over here, these two factors are both being raised to the first power. So the multiplicity is 1. You could also graph it and look at it, by the way. But if the multiplicity is odd, that means it crosses through the x-axis at those x-intercepts. If the multiplicity is even, then it touches at that x-intercept. So the first question there, the graph crosses the x-axis where? It crosses the x-axis at -1 and +1. Does it touch the graph? Yes, it touches the graph at the 0, the x-intercept 3. All right, find the y-intercept. We're going to evaluate this function at 0 to find the y-intercept. So to evaluate this function at 0, we get -3 times 0 minus 3 squared times 0 squared minus 1. So we're going to be really careful with the signs. That is going to be -3 squared times -1. But anytime I square a real number, I get a positive. So this is -3 times 9 times -1, and that's going to be positive 27. So it crosses the y-axis at 27. This function is neither even or odd. There is no symmetry to this function, and you can certainly see that from its graph if you were to graph it. All right, so which one is it of these 4 graphs, A, B, C, or D? It's either A or C, because those 2 graphs have the correct end behavior, where it's falling to the left and falling to the right. And it has to be A, because graph C only has 2 x-intercepts, and our graph has 3. So it has to be A. If we were to blow graph A up, we'd see that it crosses the x-axis over there at -3. It goes up. It crosses through I said -3, through -1. It comes up and goes back down. It crosses at +1, and then it comes up and touches at 3. Okay, Descartes. No, long division. We're going to do long division on these 2 polynomials. We're going to divide the 9x to the third plus 3x squared plus 9x minus 10 by 3x squared minus 2. All right, so to do this long division, we look at the dividend, the first term in the dividend, and the first term in the divisor, and we divide those. So 9x to the third, let's write it over here, divided by 3x. 9 divided by 3 is 3. X to the third divided by x is 3x squared. So that is the first term in our quotient. Then we take our quotient and multiply it times our divisor. 3 times 3 is 9. X squared times x is x to the third. And we get minus 6x squared. Okay, we're going to subtract. Whenever we do a long division, when we get that divisor times our quotient, we subtract that from the dividend. So this is going to be what? 3 plus 6 is 9x squared. The degree of our dividend is not less than the degree of our divisor. So we have to bring the next term down, which is the 9x, and we repeat the process. 9x squared divided by 3x is going to be 3x. So that's the next term in our quotient. We multiply quotient times divisor. We get 9x squared minus 6x. And we subtract. So that changes that sign of that -6 to +6. We add 9 and 6, we get 15. X, the degree of 15x is 1. The degree of the divisor is 1. So since the degree of the dividend is not less than the degree of the divisor, we're not done. So we have to bring down the -10. 15x divided by 3x is 5. So that's the last term in our quotient. 5 times 3x is 15x. 5 times -2 is -10. We subtract, and we get a remainder of 0. So our quotient is 3x squared plus 3x plus 5 with a remainder of 0. 8. Problem 7, synthetic division. All right, to do synthetic division, I'm going to have to first deal with that dividend. There are missing terms in that dividend. We don't have an x to the 4th term. We do not have an x squared term, nor do we have an x term. So I need to write those in using 0 coefficients. So this is going to be x to the 5th plus 0x squared plus 8x to the 3rd plus 0x squared plus 0x minus 9 divided by x minus 1. If you don't put those in, your columns in your synthetic division will not line up. Okay, so we're dividing by x minus 1. So our divisor is going to be plus 1. So write our divisor outside our division box. Put our coefficients of our dividend in the top row. All right, now start the synthetic division process. Bring the first number straight down into the 3rd row, and then multiply that number times the divisor and put it in the 2nd column. 1 times 1 is 1, put that in the 2nd column. Add them up. 0 plus 1 is 1, put that in the 3rd row. 1 times 1 is 1, put that in the 3rd column. 8 and 1 is 9, put that on the 3rd row. 9 times 1 is 9, put that in the next column. 9 and 0 is 9, bring that straight down. 9 times 1 is 9, write that in the next column. 0 plus 9 is 9, put that on the 3rd row. And then 9 times 1 is 9, -9 plus 9 is 0. So what is the result? You're dividing a 5th degree polynomial function by a 1st degree polynomial function. So these are the coefficients on your 4th degree polynomial quotient. So it's x to the 4th plus x to the 3rd plus 9x squared plus 9x plus 9. All right. The next problem, they give you the graph of this thing, at least partial part of the graph. And from that graph, I can see right here that 3 is an x-intercept. So from this graph, I can see that one solution to this equation is the number 3. So the solution is 3. Now I'm going to find the other 2 because there should be, it's a 3rd degree polynomial, so there should be 3 zeros. So I'm going to use synthetic division. I'm going to divide this thing by 3. So my coefficients are 1, 8, -3, and -90. Bring the 1 straight down. 1 times 3 is 3. Write that in the 2nd column. 8 and 3 is 11. Put that on the 3rd row. 3 times 11 is 33. Write that in the third column. 33 minus 3 is 30. Write that on the third row. 30 times 3 is 90, so the remainder is 0. So we confirmed that 3 is a 0 because the remainder, when I did that division, is 0. Okay, so the second degree polynomial function, the second degree polynomial factor of this function is x squared plus 11x plus 30. That's factorable. You could certainly use the quadratic formula if you want. I don't like to use the quadratic formula. There's just too many places to make errors. So if I set x plus 6 equal to 0, I get x is negative 6. That's another 0. If I set x plus 5 equal to 0, I get x is negative 5. So that is the third 0. Third x-intercept. Third solution to that equation. They all mean the same thing. All right, problem 9. The following equation is given. Complete parts A through C. So the first part of this, they just want you to list all the possible rational zeros. And you can use the plus or minus. That's going to be in your toolbar, so you can use that. So what are all the possible rational zeros? Well, it's factors of the constant, which would be 18, over factors of 1. Well, the factors of 1 are plus or minus 1. So we're really only concerned with the factors of 18 because we're going to divide those factors of 18 by 1. So that's just going to give us that factor. So that's going to be plus or minus 18 is a factor of 18, as is plus or minus 1. What's next? Plus or minus 9 is a factor, as is plus or minus 2. And then plus or minus 6 is a factor, plus or minus 3. So I think that's all the factors of 18. So I would take those factors and I'd type that into that field in part A. Okay, which one of these is a factor of this thing? Well, I could use synthetic division as they suggest. I'm going to graph it. And I could probably get all 3 zeros from the graph, but I can at least get 1. So that's what I'm going to do. So let me share my computer, share my calculator. All right, so I am going to graph this. So I'm going to go to my y equals, and I have x to the third minus 2x squared minus 9x plus 18. I'm going to do a zoom standard to get a standard window. All right, I can see all the zeros now. So it has a 0, it crosses at -3, it crosses at 2, it crosses at 3. So I know all 3 of the zeros from the graph. Okay. So I know 3 is a 0. I saw that on the graph. And I could use synthetic division. Oops, I put that in the wrong spot. Sorry about that. Put that in the second one. This is where these rational zeros are going to go, right there. All right, so we could divide this by 3 just to confirm that I've graphed it correctly. Bring the 1 down. Okay, I can add. All right, so this is the quadratic factor of this. That's x minus 6. If we set that equal to 0, we'd get plus 3 minus 2. If we factor it, so that would give us -3 and positive 2. So use the root from part B and solve the equation. So what are all the roots of this thing? -3, 2 and 3 in no particular order. Oops, sorry about that, folks. So x plus 3 is 0, x minus 2 is 0, x is -3, x is 2. All right, Descartes. Finally, we get to Descartes. Descartes' rule of signs. How many positive or negative zeros can this function have? Okay, I'm going to first look at the function the way it's written. So I have negative, get my eraser here. I have -6 x to the third plus x squared minus 6x plus 6. How many sign changes do I have? Well, there's 1, there's 2, there's 3. There are 3 sign changes from negative to positive. So there are 3 sign changes. So I have 3 possible positive real zeros. But I subtract 2 from that number until I can't subtract 2 anymore. So 3 minus 2 is 1. So this function, this polynomial function, either has 3 positive zeros or it has 1 positive zero. So either all 3 of them are positive or one of them's positive and the other 2 may be negative or imaginary. So what I do now is I evaluate the function at negative x. And the easy way to do that is just to change the sign of every term of odd degree. So the -6x to the third becomes positive. The even degree functions, you don't change their sign. And there are no sign changes. So there are no negative zeros for this function. They're either all 3 positive, one's positive, and the other 2 are imaginary. It's one of those cases. Either all of them are positive or one of them's positive and the other 2 are imaginary. And you could certainly graph this and look at this and see how many of the zeros are positive. I think all 3 of them are, if I remember correctly. But it's either 3 or it's 1. You got 3 zeros, so either all of them are positive or one of them's positive and the other 2 are complex. All right, problem 11. Find all the zeros. So this one, you're just going to find the zeros. And you can use whatever method you want to use. I do need to find the first zero that I can use in synthetic division. And to do that, I'm going to graph this thing. That's the easiest way to find the first zero. If the thing crosses the x-axis or touches the x-axis at all, that's going to be a 0. So I'm going to go share my calculator. All right, so I'm going to go to my y equals, and I'm going to type in this function. So I have x to the fourth, arrow out of there, plus 62x squared, plus 128x, plus 65. Okay, I'm going to hit the graph button. Okay, so whatever else this graph does, it touches the x-axis at -1. That means that 0, -1, is of even multiplicity. So either -1 is repeated as a 0 twice, or since this is a 4th degree polynomial, it's repeated 4 times. So it's either repeated twice or 4 times because the multiplicity must be even at -1. All right, so I'm going to go back and I am going to divide this thing by -1. So using synthetic division, I'm going to divide by -1. So I'm going to put my coefficients. I've got a 1. I have a missing x to the third, so I need to put that in with a 0. If you don't put in the missing terms with 0 coefficients, your synthetic division will not line up properly. So bring the 1 down. -1 times -1 is +1. That's 63. That's -63. That's 65. That's -65, which is 0. So there is the third degree factor of this function. I'm going to divide it by -1 again because I do know that -1 is repeated at least twice. So I'm going to do that division again. Okay, bring the 1 down. All right, so these are the coefficients. I've divided a fourth degree polynomial by a first degree polynomial. I got a third degree polynomial. Then I divided that third degree polynomial by a first degree polynomial again. So those are the coefficients on the second degree polynomial factor of that function. So this is x squared minus 2x plus 65. So this thing factors to, if you're interested, it factors to, since -1 is a 0, x plus 1 is a factor. So x plus 1 squared times the x squared minus 2x plus 65. Now, that thing is not factorable. I'm going to have to use the quadratic formula on it. So I'll might as well go ahead and do that. So I changed the sign of b, so positive b, excuse me, +2. And then I'm squaring b underneath the radical. -2 squared is 4, minus 4 times a. A is 1. C is what, 65? And the whole thing divided by 2 times 1. And I suspect these are complex just because I know Professor Castle. So this is going to be 4 minus, I'm going to take 4 times 65, and that's -260 minus 260, because I do have a minus sign in front of that, and I'm dividing by 2. 4 minus 260 is -256. The square root of -256 is 16i. If you're taking the square root of a negative, you're going to get an imaginary number. So that's 2 plus or minus 16i divided by 2. And I can cancel a 2 because a 2 is in both the terms in the numerator. So it's 1 plus or minus 8i. So what are the zeros here? -1 is a 0 repeated twice, and 1 plus or minus 8i is the complex conjugate zeros of this thing. Okay, what's the domain? Well, x can't be -17, and that would cause an issue. So x can be anything else but -17. There's a hole there, so it can be anything to the left of -17, which would be -infinity to -17. Do not put a bracket next to that. Or anything bigger than 17, 17 to infinity. Just can't be 17. It can be anything else, it just can't be 17. Problem 13. Follow the 7-step process for graphing a rational function. All right, there is no symmetry to this. You could graph it and look at it. There isn't going to be any symmetry. Okay, what's the y-intercept? To find the y-intercept, you evaluate the function at 0. So f of 0 is going to be what? 0 minus 5 divided by 0 squared minus 25. That's -5 over -25, which simplifies to 1/5. The x-intercepts, to find the x-intercepts, I do need to factor this thing and cancel any common factors. I need to do that to find the vertical asymptotes anyway, But if the numerator cancels with a factor in the denominator, there's not going to be any x-intercepts. So let's go back up here and factor this. That denominator is the difference of two squares. X squared is a perfect square, as is 25. So it's going to factor to a sum times a difference, the sum of the square roots. So the square root of x squared is x. The square root of 25 is 5, x minus 5. And the x minus 5 does cancel. X minus 5 divided by x minus 5 is 1. So you end up with 1 over x plus 5. Okay, so the numerator is where you find the intercepts, the x-intercepts. You set the numerator equal to 0 to find the x-intercepts. Well, you can't set that numerator equal to 0 because it's 1. So there are no x-intercepts. This thing does not cross the x-axis or touch it. All right. What are the vertical asymptotes then? Well, since I canceled the x minus 5, I get a denominator of x plus 5. So we set that equal to 0. So there is an asymptote at -5. But since I canceled the x minus 5, x can't be 5 either. It can't be 5. You can't cancel 0 over 0. So since it can't be 5, that is a whole. So the factor that you cancel gives you wholes. The denominator gives you asymptotes. So which one do we pick here? This would be C, I believe, because we have an asymptote, and I do need to write the equation of the asymptote. And then the second field where you put the whole, they give you the x equals there, so you just have to put in where the whole is located. Okay, does it have a horizontal asymptote? And the answer is it does. The denominator's degree is 2. The numerator's degree is 1. If the denominator's degree is bigger than the numerator's degree, then the x-axis is a horizontal asymptote. So y equals 0 is a horizontal asymptote. All right, now, how it's going to want you to find these 5 ordered pairs that are on the graph of this thing. That is not an uncomplicated arithmetic calculation. So I'm not going to make that arithmetic calculation. I am going to let my calculator do this for me. Let me show you how we do that. So I'm going to share my calculator. Okay, so here's what we do. We're going to graph this thing. So I'm going to go alpha, y equals number 1. It gives me my fraction. And I am going to type in that rational function. So I got x minus 5 in the numerator. And in the denominator, I have x squared minus 25. And I'm going to graph it. All right, so there's the graph. And you can see that vertical asymptote at -5. And if I look at the table, so I go second graph to get to the table. Oh my goodness, look at that. Actually, I need to do a table set on this. This is set for another problem we're going to do here in just a minute, but I don't really want the x's to go by halves because the numbers I'm looking for are -8, -7, 4, 6, and 7. Those are integers, so I really want my table set to be in integers. So my table set is above the window. So I'm going to go second window, and I'm going to start maybe, where do we need to start? -8. That's the first number we're going to evaluate. And I want my table set to go by ones. And that'll help me quite a bit finding those values. Now, when I look at the table, second graph, there you go. So at -8, y is -1/3. Type that in. At -7, y is -1/2. Type that in. You can see that there's an error at -5 because that's the asymptote. So next we need to know what y is when x is 4. When x is 4, y is 1/9. When x is 6, you can see the hole at 5. When x is 6, y is 11th. And when x is 7, y is 1/12. So I just go type those values in. Let the calculator calculate those for you. Why not? Okay, so we're going to go type those in the appropriate fields. So we have -1/3, -1/2, 1/9, 1/11th, and 1/12th. Now, my graph got cut off, but you certainly are going to graph this on your calculator, so you would be able to choose the correct graph. Mine just got cut off because of the way it printed. So this is D. All right, problem 14. Find the slant asymptote. Okay, to find a slant asymptote, I actually have to do the division. That dividend x squared plus x minus 2 divided by x minus 2. Now, since the divisor is linear, I can use synthetic division. So 2 divided into 1, 1, -2. And as soon as I get the first two coefficients, I don't really need to find the remainder because the slant asymptotes equation is going to be, and you do need to type in the y equals whatever you get for that quotient. So bring the 1 down, 2, 3, and you're done. So it's x plus 3. X plus 3 is your slant asymptote. Okay, there is no symmetry here, no symmetry. I don't think we have any problems with symmetry, but you could certainly graph it and look at it. What's the y-intercept? When we need to evaluate this function at 0, which is going to be -2 over -2, which is 1. X-intercepts, well, I do need to graph this, factor this thing to make sure nothing cancels. So that's going to be x plus 2, x minus 1. X minus 2, so nothing cancels. So we set the numerator equal to 0, and we would get what? -2 and +1. Those are our x-intercepts. And then the equation of the vertical asymptote, well, we set the denominator equal to 0 to find the vertical asymptote, so that would be x is 2. Horizontal asymptote, well, the degree of the numerator is larger than the degree of the denominator, so there is no horizontal asymptote. If the degree of the numerator is larger than the denominator, there is no horizontal. Okay, and then we're going to do the same thing we did before to calculate this function's value at these various x's. And I'm going to start using a table set of integers. And then to get that 5/2, I can go back in and change the table set, or I'm going to show you another way of evaluating this function at 5/2. There's multiple ways to evaluate a function once you've graphed it. So I'm going to share my calculator. Okay, so let's go into our y equals and let's graph this thing. So alpha y equals number 1. And I'm graphing x squared plus x minus 2 over x minus 2. Graph it. So you can see that slant asymptote by the way this graph, how it looks. You know there's a slant asymptote there. Okay, so let's do the table. And we can find the various values. So at -4, let's go up to -4. At -4, this thing is -5/3. So I would type that in. At -3, it's -4/5. I would type that in. At -1, it's 2/3. Type that in. I don't know what it is at 5/2. So I'm just going to skip over that one for now. At 5, it is 28/3. So I could go back and do a table set and change it to 1/2. So you go second table set. The delta table, you'd want to change it to 1/2. So 0.5 is 1/2. And then when you look at the table, now the delta, each one of these is going to be at 1/2. So 5/2 is 2.5. So it's 13.5 there. I would have to convert that to a fraction, which I could do. The other way you could do this is you can find the function value at a particular x. So you go to your calculate menu, which is above the trace, and number 1 is value. It will calculate the y value for a given x. Well, who knew? Okay, and what x are we calculating for? 5 divided by 2, 5/2. You hit enter, 27/2. Oh my goodness gracious, isn't that easy? So we type that in. So we go second trace to get the calculate menu. Number 1 is value. It will calculate the y value of a function for a given x. All right, so we got all that typed in. And then which graph is it? Well, I just graphed it a second ago, didn't I? And it's going to be B. The rest of them do not have the asymptotes in the correct place, and the graph doesn't look correct. All right, problem 15. Inequalities. You could certainly graph this and look at it and determine where this function is below the x-axis, because that's what it says. It's negative. Less than is a negative number. So you're looking for where the y values are below the x-axis. That is the interpretation of that inequality. I also can do it by looking at the signs of test values in the intervals that are formed by the boundary points. So to find the boundary points, you factor the function. And you set it equal to 0, so that's going to be 5 here. Excuse me. And 1 here, the other way. So this one is going to be minus, and this is going to be plus. Okay, does that factor correctly? 2x times x is 2x squared. 2x times 5 is 10x. Minus 1x is 9x, the middle term. -1 times positive 5 is -5. So from this one, we get x is 1/2, is one boundary point, and x equals -5 is the other boundary point. So our intervals are going to go from -infinity to -5, and we are going to put a bracket because we have less than or equal to -5 to 1/2 and 1/2 to infinity. So then you're going to pick test points in the various intervals. So pick a test point. So you could pick, I don't know, anything less than -5, anything smaller than -5, maybe -6. And then something in between -5.5, well, that would be 0. That would be the point I would pick. And anything bigger than a half, well, 1 is bigger than a half. And then you're going to evaluate this function at those values. And if I evaluate this at -6, I have no idea what that number is going to be, but I do know it's going to be positive. So I just looked at it and determined that I'm going to have 36 times 2 is 72. 72 minus 6 is whatever that is. 72 times 9 times -6, excuse me, -54. And then we're subtracting 5. Well, that's going to be a positive number. And when I put in 0, I get a -5, so that's negative. And when I put in +1, I get 11 minus 5, I get 6. That is a positive number. So where is this thing negative? It's negative from -5 to 1/2. If it's negative for one number in that interval, it's negative for all the numbers in that interval. So we get from -5 to 1/2. And we do use brackets because we have less than or equal to. All right, so which graph is this? Between -5 and 1/2, is that D? All right, 16. This is a rational inequality. And a rational inequality, to find the boundary points, you set the numerator equal to 0 and you look at the asymptote. So if you set that numerator equal to 0, you're going to get a -11 and a 13. And the denominator, the asymptote, would be at x equals -9. So those are our boundary points. So we're going to go from -infinity to -11. And we're going to put a bracket there. And we're going to go from -11 to -9. And we're going to put a parenthesis there because the denominator cannot be 0, so x cannot be -9. So next to the -9, I must put a parenthesis. Now, next to the zeros in the numerator, we're going to put a bracket. So from 13 to infinity. Okay, and then pick a test point, -12, -10, 0, and maybe 14. And then check the sign. So at -12, this thing would turn out to be negative. At -10, this thing would turn out to be positive. At 0, it is negative. At 14, it is positive. So where is it negative? Because that's what we're looking for. It's negative from -infinity to -11. And from what? From -9 to 13. Make sure you put that parenthesis next to the -9. So which one is that? Is that A? Okay, last two problems are on proportions. We have y varies inversely as x, y varies inversely as x. Y is 18 when x is 5. Plug that in to find k. 18 equals k over 5. So multiply both sides by 5. And we get k is 90. So our equation is y equals 90 over x. And we are interested in what? What is it when x is 2? When x is 2, y is 90 over 2, which is 45. The height of that a ball bounces, so I'm going to use B is the height it bounces, varies directly as the height from which it is dropped. So I'm going to let H be the drop height. And B varies directly as the height that it's dropped. So B equals K times H. Okay, so what do we know? A tennis ball dropped from 18 inches, bounces 7.2 inches. So make those substitutions. Divide both sides by 18. So my handy dandy calculator says 7.2 divided by 18 is 0.4. So my equation is B equals 0.4 times H. And then what do they ask me? From what height, so actually we're solving for H, was the tennis ball dropped if it bounces 40 inches? So if it's 40 inches, what is H? So divide both sides by 0.4, and I get D is 100. And they do ask you for units here, which is kind of nice. Well, your units are all in inches, are they not? Because you're looking at the height at which a ball is dropped and the height at which the ball bounces.